Welcome in, everyone. I am absolutely thrilled to have you here for this explainer. If you've ever stared at a super interactive web app and thought, how in the world does this not just collapse under its own complexity? Well, you're exactly in the right place. Building a modern UI is kind of like assembling a massive shifting puzzle while you're holding it. Today, we're unpacking the absolute ultimate blueprint for that puzzle, React.js. We're going to break down how this incredible tool gives you the exact organizational building blocks you need to build fast, scalable, and just stunning digital experiences. Let's get to it.
So let's just dive right in. React.js is officially defined as a declarative JavaScript library for building user interfaces using a component-based architecture. But what does that actually mean for us as developers? Basically, it means React isn't just a basic tool, it is a total paradigm shift. Instead of micromanaging exactly how the browser updates the screen step by step, imperative programming, React lets you just declare what the final UI should look like. You just tell it what you want, and React handles all the heavy lifting to make the screen match your description. It's brilliant. Here is our architectural blueprint for today. We're going to build this knowledge sequentially. First up, the React revolution. Then, components and JSX basics, followed by the power of props. After that, we'll cover interactivity with state management, and finally, smart rendering and structure. Part 1, the React revolution. Let's look at why React totally changed the game compared to everything that came before it.
Think about the contrast between a sluggish snail and a lightning bolt. In traditional web development, whenever a user clicks a button, the browser redraws massive chunks of the screen. That's our snail. But React's virtual DOM? Total lightning bolt. It is basically a lightweight copy of the screen that React keeps in memory. So when a change happens, React calculates the absolute bare minimum number of changes needed, updating only exactly what changed. No redrawing the whole page. It's incredibly fast, super efficient, and a massive performance booster.
Getting your hands on this power really just takes 3 simple steps. 1, install Node.js and npm. 2, run npx create React app, my first app. And 3, run npm start. Now, I know modern alternatives like Vite are incredibly fast and super popular right now, but this classic create React app setup, it generates the perfect scaffolding if you're just getting started. It gives you this incredibly clean structure with source and public folders, so you're literally ready to start coding in minutes. Moving right along to part 2, components and JSX basics. If the virtual DOM is the engine, components are the chassis and the wheels. Think of them exactly like Lego blocks. They're individual, reusable pieces of code that snap together to build incredibly complex interfaces. It's amazing how elegantly a simple function bridges the gap between logic and visuals here. You just write a standard JavaScript function, returning what looks exactly like HTML. It's clean, it's readable, and it's the foundational building block of your whole app. But as you level up, you'll want to separate these blocks into 2 distinct types. First, you've got presentational components, which just focus on how things look. Then container components, which handle all the behind-the-scenes logic, data fetching, and state. Organizing things this way is the absolute secret sauce to highly maintainable code. Now you might be wondering, why on earth are we writing HTML inside a JavaScript function? Well, that is JSX, or JavaScript XML. Under the hood, React uses standard JavaScript to build the UI, but trying to write complex, nested UI structures that way gets incredibly messy very fast. JSX solves this beautifully by letting you write visually intuitive, HTML-like markup directly inside your logic files. It makes your entire codebase drastically easier to read and maintain. Because JSX isn't quite regular HTML, there are a few physical rules for how our Lego blocks have to click together. If you're returning multiple elements, you gotta wrap them in a single parent tag. Assigning a CSS class, you have to use class name instead of class because class is a reserved word in JavaScript. Empty elements absolutely must be self-closing. And here is the real magic. To inject dynamic JavaScript directly into your UI, you just wrap it in curly braces. It is that easy. Let's jump into part 3, the power of props. Okay, we've got our static Lego blocks, but how do we make them dynamic? How do these individual pieces actually communicate with each other? The answer is props, or props for short. Imagine a simple greeting function. It accepts an argument called props, and we inject props.name right into our header using those curly braces we just talked about. This block is now completely reusable. We can say hello to Alice or Bob or literally anyone simply by passing a different name down from the parent component. And here is a cool pro tip. Props don't just have to be simple text or data. Ever heard of the render props pattern? You can actually pass entire functions down as props to share complex behaviors between components seamlessly. It's a total game changer. To truly master props, there's one golden rule you have to remember. They are strictly read-only instructions from above. Never, ever try to change them from within the child component. They are immutable. But honestly, perhaps the most powerful prop of all is the children prop. React heavily favors a concept called composition over inheritance. By using the children prop, you can create a generic card or dialogue component, and then pass completely different custom elements directly inside it. It's literally like building Russian nesting dolls with your UI.
All right, part 4, interactivity with state management.
Okay, so if props are just read-only instructions from the outside, how do we build apps that actually change and respond to the user? Well, components need their own internal memory. And that brings us to state. This is notoriously confusing for beginners, so let this be your anchor. Props are external and immutable. State is internal and mutable, meaning it changes through user interaction. But what happens if two different components need to share the exact same piece of state? You use a really powerful pattern called lifting state up. You simply move that state out of the child components and up into their closest common parent, and then you just pass it back down to them via props. Problem solved.
So how do we actually use state? When we use the useState hook, it gives us an array with two things, a variable holding the current value and a dedicated function to update that specific value. By pairing these together, React knows exactly when to trigger a re-render of the virtual DOM. But here is an advanced insight for you. If your new state depends on the old state, like if you're incrementing a counter, always pass a function into your update method. So instead of just setting the count directly, use something like prevCount arrow prevCount +1. This guarantees you are always working with the freshest data, which prevents some really weird bugs down the line. And we actually trigger those state changes through event handling. It's very similar to plain old HTML, you just use camel case. When a user clicks a button, an on-click event fires, which then triggers your state update function, and React beautifully and efficiently updates the UI. Oh, and a quick heads up, just remember to use e.prevent defaults in your form submissions. If you don't, you might accidentally refresh the entire page and wipe out all that state you just carefully managed. Moving to our final section, Part 5, Smart Rendering and Structure. As your application grows from a simple button into a massive, complex dashboard, rendering efficiency and code organization become your absolute top priorities. When you're rendering lists of data, React uses the standard JavaScript map function, but pay close attention to the key prop. This is absolutely critical. React uses this unique key to keep track of individual items in the list. If an item is added, removed, or reordered, that key tells React exactly which element in the virtual DOM needs to be updated. Forgetting this will cause massive performance bottlenecks, so always remember your keys. React also lets you be remarkably smart about what you actually show the user through conditional rendering. The best part? You don't need to learn any special framework-specific syntax. You just use standard JavaScript. You can use ternary operators to quickly toggle between two views, or the logical AND operator to render something only if a specific condition is true. It gives you completely precise, granular control over your interface based directly on what's happening in your component state. To survive and thrive in large-scale projects, adopting professional best practices is a total must. Always use Pascal case for naming your components, organize your folders cleanly by feature, and utilize tools like ESLint and Prettier to keep your code formatted. And as you really master React, you'll start using advanced organizational patterns, things like higher-order components. These are amazing because they let you wrap your UI with reusable logic, like checking if a user is authenticated before showing them a page. Finally, do yourself a huge favor and always install the React Developer Tools browser extension. It is an absolute lifesaver for inspecting your props and state in real time while you build. You now possess the ultimate blueprint. You know exactly why the virtual DOM is lightning fast. You know how to compose presentational and container Lego blocks with JSX. And you know how to bring all of them to life using state and props. You're no longer just writing lines of code. You are architecting digital experiences. So the final question isn't just what interface you're going to build first, it's how will you compose it to perfection. Thank you so much for joining me on this explainer. Now get out there, open up that code editor, and start building.